So, today we shall be continuing our discussion on the search engines and web crawlers. Now, if you recall our last day's discussion, in our last lecture we basically talked about some of the underlying principles which are followed by the search engines, like how they decide on the relevancy of a page, how they extract keywords from a given document, how they judge the goodness of a document, and so on. So, today, as I said, we shall be looking at the web crawler search engine, how it works, and this will possibly give you a fair idea about the design or the architecture of a search engine. Based on that, you will be able to design your own search engine if you want to. So, we shall be talking about web crawler. So, this web crawler, as I said, web crawler was a crawler based search engine which was developed in the 90s, and it gained quite a bit of popularity because at that time crawler based search engines were not that readily available, and many of the other existing commercial search engines, they used the web crawler services to integrate the search results into their web pages. So, web crawler is the topic of our discussion today. So, let us see what web crawler is basically first. This I mentioned already. Web crawler is basically a tool that helps us in solving the resource discovery problem in the World Wide Web. Well, the problem of search, we are recasting it here as a resource discovery problem. Searching and resource discovery is similar. We are trying to discover some resources in the web, where they are located, we are searching for them. So, it is basically the same thing. Some of the features of web crawler are like this: it navigates the web automatically on demand. Now, this demand can be driven by the website or by the search engine which is using web crawler for crawling the web. So, it has the capability of crawling or navigating the web automatically. This is important, I mentioned in the last class, because the web is changing very fast, both in terms of its size and also in terms of the, you can say, the lifetime of some of the pages in the web, which changes very fast. So, to perform the indexing, what web crawler does, it accesses the web documents one at a time, sometimes taking decisions based on information available locally. Using this kind of an information, it tries to create the web index. So, the principle is essentially the same. It has to go from one document to the next. At any given time, it will be looking at one particular document. So, basically the web crawler is an integrated piece of software, that is why it is called a single piece of software, but with two different functions. The functions are, firstly, building index of the web pages. This is the most important function naturally, and secondly, for the purpose of building indexes, it has to go from one web document to the other. So, navigation of the web in an automated way, this is also one of the main functions of the web crawler. So, these are the two main functionalities. The key design goals of web crawler were that the indexing should be carried out based on the contents of the document, not based on the title or something, the name of the page, like it is contents based indexing, depending on or based on whatever is there in the body of the document, indexing has to be carried out accordingly. So, what web crawler does, it carries out breadth first search over the web to create a broad index. Now, when we talk of this breadth first search, essentially the entire web is treated or is visualized as a graph, because you know in the web we have so many pages, there are hyperlinks which are pointing to other pages. So, if you treat the hyperlinks as edges in a graph and the web servers as the nodes, so essentially we are looking at a graph. So, when you talk about going from one page to the other, basically we are traversing the graph by following the edges from one node to the next. Okay. This is the basic problem visualized or viewed as a graph theoretic problem. So, the crawler behavior is utilized to include as many web servers as possible, because this is one important thing. Why? Earlier we had said that the number of total web pages is huge. A particular search engine may possibly cannot afford to index all of them. They have to consider a subset, but which subset? This is one big question. So, here what I am saying is that when you say that crawler behavior is in such a way to include as many web servers as possible. Why? What we mean here is that when you say that a subset of pages must be fetched, we say that a subset should be such that there should be one page, one representative page from every web server. If there are 100 web servers, there should be at least 100 pages, one from each. Okay? Because when you get a page from a web server, from that page some information about the other pages available locally can usually be found out. So, this is the strategy which has been adopted by web crawler. You know, World Wide Web has a dynamic structure. The creation of the web is decentralized. There is no one who has central control over the design of it. So, any individual who has access to the internet can add contents to the web. So, I can run a web server on my machine, I can create some web pages, I can provide hyperlinks to other pages. No one can stop me from doing that. This is why we say that the World Wide Web has a dynamic structure. The structure, again looking at it as a graph, the graph changes with time dynamically. New nodes get added, some pages get deleted, means some nodes get removed, and so on. So, the design implications of this point is discovering new documents and keeping the database updated forms a very important component of the design. This is perhaps the most important issue, because if you cannot do it in a good way, your search engine cannot be that good, because how good you are able to do the indexing, this entirely will dictate how good your search engine will be. Okay. So, discovering new documents, obviously this is done by traversing uniform or universal resource locators, URLs. So, URLs are a means of locating or going to a document for retrieving it. They can in general refer to any retrievable network resource. It can be another HTML document, it can be an image, it can be an audio clip, video clip, or it can be also an executable file or some mail URL or some other kind of URL. Okay. So, after retrieving a document, the web crawler will perform the following actions. Suppose the web crawler visited a page following a URL, retrieved it, then it will carry out the following. It flags in its own database that the document in question has been retrieved. It looks for any outbound hyperlinks in the document, because if there are some hyperlinks going out of the document, they may also have to be traversed in the future. and it looks at the contents of the document and carries out indexing. It indexes the contents of the document, and all these above three operations, they will require some information to be stored in a database and of course access to the database, right. Fine. So, pictorially the architecture of web crawler looks like this. We shall be looking at each of these individual components. So, you can see there is the internet out here, there is something called query server, database is of course there, search engine, agents and some library libwww. Let us see how these individual blocks in this diagram interact among themselves and what are their respective functions. So, the various components of the web crawler are as follows. Firstly, we have a search engine. Search engine, actually you can say this is some kind of a front end or the interface to the user. The search engine will be responsible for deciding which new document to explore and for initiating the process of the retrieval. See, here you can see that the search engine has two different roles depending on how or in what mode you are using this web crawler. Since the web crawler is run in two different modes. One, when it is trying to discover new documents, it is crawling the web and creating the index. Number two, when some user has given a query, it searches the database for the index and looks for matches. So, when it is the first one, then the search engine will decide how to select the next document to explore, and when it is in the query processing mode, it will initiate the process of the retrieval of the documents. Next comes the database. Now, in the database, as I said, you need to store a number of different things. You can store some information about the document. This is the document metadata. Document metadata can also contain the keywords. Full text index can be separate also. Full text index are the text based keywords based on which you have indexed the document, and of course the hyperlinks between documents. From this document, where else are the hyperlinks pointing to? Then you have agents. These agents are responsible for retrieving the documents from the web under the control of the search engine. So, you just understand the role of the agent. So, this agent is some kind of a tool which is running under the search engine, and it is the responsibility of the agent to retrieve the information requested from the web and give it back to the search engine. So, agent also plays a very important role in this, in the overall scenario. Then you have the query server, which handles the user's queries. It is responsible for handling the query processing service. And lastly, you have the libwww. This is exactly not a separate module or a software, rather this is a library. This is a standard library available, CERN www library. This library is used by the agents to access several different kinds of contents using several different protocols. Like this libwww will contain all the information about HTTP, FTP, then the image documents, whatever the different protocols which may be running and how to retrieve them. Gopher may also be there. So, all these things are part of the libwww package. So, this libwww package is basically used by the agents before it can access the internet to retrieve the contents of the document that have been requested. So, just looking at the diagram once more, now we can understand the role. Search engine in one respect, when it is trying to build up the index, it is crawling, it will be taking help of the agents. Agents will be using this libwww to search the internet. But when you are in the query processing mode, the search engine will be building the database. So, the query server will be simply querying the database. Okay. So, you see that there are two different modes of operation here. One is while the index is being created, and number two, when the index is already there in place in the database, the user has typed in some query and the queries are retrieved by matching against the indexes from the database. Fine. So, let us now look into the search engine in some detail. The basic requirement of the search engine is discovery of the new documents. Web crawler has to discover the new documents. So, how does it perform this step? Well, web crawler typically starts with a known set of documents. These URLs can be provided a priori. From this known set of documents, it will examine all the hyperlinks that are pointing from them to other pages, and will be continuing with the discovery following those hyperlinks. So, this process will be repeated recursively. Recursively because whatever you are doing from the present page, you will also be doing the same thing from the page you will be visiting by following the link. There also you will also have to look at what are the links to other pages, again you will be following them, again from there you will be doing the same thing. Okay. So, this is a recursive process. So, as I said, alternatively we can view the web as a graph. So, the alternate way of looking into this problem is the web is regarded as a huge directed graph. The documents are the vertices or the nodes, the hyperlinks are the edges. So, basically this search problem now reduces to a graph traversal algorithm. So, now we are forgetting web, we forget everything, we are saying that we have this graph and we will have to carry out some kind of a graph traversal using some criteria or fulfilling some, you can say, requirements. So, this diagram just shows you how we can visualize the web as a graph. These rectangular boxes are representative of the different websites. So, maybe inside the same website, this particular document may be pointing to two other documents, this and this. Okay. Similarly, in some other website, this document may be pointing to other documents. Now, across websites there may be pointers, from this document it is pointing to this document. Okay. So, in this way you can have cross referencing. So, overall you see that this is a graph like structure, directed graph. So, this is what we are talking about. So, when we have this kind of graph like structure, we will have to formulate our graph traversal algorithm in a proper way, so that we know exactly what we are trying to do. Okay. Some points here about the search engine. Now, let us see that what are the main roles of the search engine. The search engine is responsible for which documents to visit and also types of documents to visit. So, which documents to visit is of course important. This we had said you can follow the hyperlinks, you can also have some additional criteria imposed, but it says it will also be responsible for the types of documents to visit, because we try to understand our requirement. We are visiting the documents for the purpose of indexing. After visiting a document, we shall be looking at the contents, we shall possibly be extracting some keywords, and those keywords will go into the dictionary, and this document will be said to be indexed after that. But suppose if I get some information from a website which is not such a readable document, like it is an image, it's an audio clip, video clip, PS file. So there you cannot so easily evaluate or index the document with respect to contents. If you are downloading an image, you can say that this is an image file, just by looking at the name of the file you can index it with the name, but you really cannot do some indexing based on the contents. You really do not know what is there inside that file. Okay. So from the point of view of indexing, it is not justified to bring or retrieve any file which will not give you any additional information with respect to indexing. So web crawler follows this principle. It does not retrieve any files which it cannot index. No point in retrieving files that the web crawler cannot index. This is the principle which it follows. Which it cannot index, some examples I have already given: images, audio clip, video clip, PostScript file, because even if you retrieve them by mistake, during indexing they are simply ignored, because you will not be looking at their contents in any case. Okay. Now, as I said, that web crawler carries out searching in two different modes, while it creates the index and while it responds to a user query. So these are the so called indexing mode and the real time search mode. So let us see how these two work. Now in the indexing mode, as I said, the main purpose is to crawl the web and create the index. Obviously the objective would be to index as much of the web as possible, but how the web crawler can ensure this? Let us see. So the basic motivation, as I said, is to try and build an index of as much of the web as possible. This is a keyword, as much of the web possible, understanding that it is not practically feasible to index the whole of the web. Okay. So web crawler uses some heuristics. These heuristics try to answer some questions. Which documents to select if the space for storing indices is limited? Of course, a reasonable approach, as I mentioned earlier also, is to ensure that documents come from as many different servers as possible. Suppose you have space only to store 100 index values, make sure that those 100 index values come from 100 different websites, not 50 pages from the same website. Okay. This is the principle which web crawler follows. So based on this criteria, web crawler uses a modified version of breadth first search approach in order to ensure that every server has at least one document that has been indexed. So it is basically breadth first search, but not across pages, but across websites. So when it is exploring or crawling with respect to the hyperlinks, it is also keeping track of the fact that which are the websites which have already been explored. If a website has been explored, you just do not go there and explore it again. Okay. So if you do it, it will be just be a modified breadth first search. If a page has not been visited, but the website from where it is coming has been visited, that is also considered as visited. This is the modification of the breadth first search. So, using this modified version, you can ensure that at least one page from every website is fetched, retrieved. So, it will be like this: every time a document on a new server is found, the server is marked as visited, not that the web document is marked as visited. You are marking the server as visited. This is the keyword here. All the servers being pointed to by hyperlinks are put on an open list. The process is repeated. You look for a server in the open list which has not yet been visited. You open it and you again follow the hyperlinks and find out that whether they point out to web servers which are not yet visited. Okay, so, this is the basic concept behind the modified breadth first algorithm which is used here. And in the real time search mode, this is the other mode I had mentioned. Here the web crawler is actually trying to answer the user queries. Given a user's query, web crawler will try to find document that most closely matches the query. So, here of course, the search algorithm will be different. See, let me tell you one thing here. There are two issues here. On one side, we are saying that we are not going to search the whole of the web. We are going to look at only a subset of the web and index them. Okay? But when you are actually searching for the documents during the query processing, there we may not like that some documents being excluded from the search. So, during that time, the documents which are not indexed in the first phase, they may also be possibly explored. So, this is something which you have to keep in mind. So, in the query processing step, the situation is not so simple. It is not that the search engine simply looks at the index database, does some database search and gives you the result. No. Depending on these keywords you have provided for search, it can also carry out additional searches, looking at additional web pages, crawling and retrieve additional pages which will be also part of the search. So, the search algorithm which is used by web crawler is a different one, not the one which is used in the indexed mode. Intuitive reasoning of this different search algorithm is as follows. Well, if we follow the links from a document that is similar to what the user is looking for, they will most likely lead to the relevant document. Like what I mean to say is that, suppose the user is looking for flower and you have one document which is indexed already in the database that is matched against the keyword flower. But if you look at the document, you find that there are 10 hyperlinks going out to other pages. Most likely those 10 hyperlinks will also be pointing to pages which have something to do with flower. Okay? So, this is how the searching is done. So, steps followed are as follows. So, the user's query is first run against the web crawler index, which means against the database. So, already in the database we have a large number of documents which have been scanned and indexed. So, when you run the query and search the database, you will get the initial list of documents which are considered to be similar with respect to the search keywords. Now, based on some way of measuring relevance, you select the most relevant documents from the list which is returned from the database. You look at these documents from the list, follow any unexplored links from these documents, because many of these documents are not indexed. Okay? So, you look at those documents which have come out of the index and follow the hyperlinks to bring those documents which are not yet been indexed. So, as the new documents are being retrieved, they are also added to the index and the query is rerun. This is done dynamically. Based on a query, you are possibly retrieving some new pages, repeating the process of indexing, and you are going on updating the database. So, the idea is that proactively you do not try to visit all the pages and start indexing. You start by an initial set of index where there will be at least one representative from each web server. Then depending on the user queries, you proactively go to other pages and try to build up the index during that time dynamically. Okay. So, this in general will lead to exclusion of a huge number of pages which otherwise are not that useful or not that sought after. So, the results which are returning out here, okay. So, they are sorted by relevance, and the documents which have the maximum relevance value, they will be the next possible candidates for further exploration. So, in this way you go on recursively expanding documents going from one to the other. So, here you find that here web crawler have introduced one interesting concept, in the sense that it is not a purely two-part process. In what part you create the index, in other part you search it. No, during searching also, if you do not find that index is there, you proactively go to other pages and you try to expand the size or the capability of your index. Okay. So, this is something which has worked quite well with this web crawler, and many of the subsequent web crawler based engines have incorporated such concepts there. There are of course some possible problems here also with this kind of a so called blind approach. Here, when we are considering one document, then all the links which are going out of a document are followed blindly, with no surety that the path being followed is a relevant one. Like for example, I have a document which talks about flowers, which is my current document. There are 10 links from there. Now, one of the links may be pointing to my own home page. There can be another link which may be pointing to some encyclopedia site. There may be another link which may be pointing to some Google or some website which I have put it in my page. So, just by looking at the hyperlinks, you cannot know that which of the hyperlinks can possibly lead to a page which is relevant in the present context. Okay. So, since the links are followed blindly, there is no surety or guarantee that the path being followed will lead you to a page which is relevant. Now, how to tackle this? Tackling this requires again some sophisticated techniques. You use sophisticated pattern matching techniques to find closest match based on anchor text. So, here the concept of anchor text comes in. Recall what is an anchor text. In an HTML document, you can specify an hyperlink. How? You can specify a phrase or a block of code as an anchor, and the entire anchor you can specify as the clickable hyperlink. So, when the document is being displayed on the screen, if someone clicks on the text, that new URL will be retrieved. So, anchor is the text or whatever which the user has to click to go to that hyperlink. Now, here what web crawler says is that you better look at what that anchor says, just do not only look at the hyperlink. The anchor might says blue rose or pink rose. Blue rose are a rare variety. So, if you click on that, possibly you will be going to a page which talks about that. Okay. So, you give more weightage to what is there in the anchor text. do some careful natural language processing on that. So, processing of anchor text can provide quite relevant and important information. This will also ensure that you do not miss the context during navigation, because if you do not do this, what might happen very soon, starting from a page containing flower, you have moved on to a set of pages which are talking about everything else other than flowers. So, you have shifted context to something else. This so means if you do it blindly, there is a definite chance of that happening, but if you do it in a systematic way, at every stage if you give importance to the anchors, if you see how they are worded, you try to understand their meaning and try to follow the links. So, this will also ensure that you are within your range or domain of interest. Now, talking about the agents which are there as part of the web crawler architecture, agents we had mentioned, they are some software code utilities or processes, you can say. They are responsible for retrieving the documents from the web under the control of the search engine. So, the search engine can find out that there are 4 hyperlinks going out. So, the search engine can ask the agents that, well, these are the 4 documents I need to retrieve, please do it. So, in order to do these things in parallel, possibly in many cases several concurrent versions of agents are spawned, maybe as processes or as threads. So, the interface to an agent will be simple. The search engine will simply give it a command like retrieve a given URL. So, if you are an agent, I will simply tell you that, well, look, this is a URL, I want you to retrieve the URL and give it back to me. This is, so the interface is very simple, input, and output what you will be giving back to me is an object that will contain the requested document. But sometimes the agent may exercise some intelligence that it will not retrieve the document, because it may feel that it is either not present, it is unable to locate that document on the particular web server, or it feels that the document is not of relevance in the present context. So, some local intelligence can also be delegated to the agent. So, agent can also filter some pages from being forwarded back to the search engine. Talking about the database, there are 2 parts to it. Full text index. Full text index are basically the keywords against which search results may be provided, and representation of the web as a graph. See, representation of the web as a graph, it can be implicit, it can be explicit. If the database contains all the pages that have been indexed, they by default contains the hyperlinks inside them. But for fast searching, information about the hyperlinks can be stored separately, which essentially means I have stored information about the graph. Okay? Storing the pages and information about the hyperlinks essentially means it is some kinds of an adjacency list. I am storing information about the vertices and the nodes which are adjacent to it. Okay. So, the database which comprises of these 2 things are stored on disk and obviously will be updated dynamically, both during the creation of the index and also during the searching, query processing. Next, let us come to the query server. Now, the query server is the module which accepts the user's queries. Typically, as I said, that the users will be entering keywords as their queries. For example, for searching for an Asian Test Symposium, I may just enter the keyword test symposium or ATS 2005, something like that. So, Depending on the user, the keywords provided may be quite detailed or may be quite sketchy. So, what the query server will do in the second step, it will be retrieving information that is stored in the database in the form of the full text index values, page titles and the URLs of the documents containing some or all of the keywords are retrieved from the index. Now, after retrieving this information, results are sorted by relevance. So, there are again a number of different ways, some simple, some quite complex, which can be used to measure relevance, and after sorting the result, they are presented to the users, so that the most relevant result will appear first. Because out of 10,000 results, if they all appear in a random order, then which are the most relevant ones, you may have to put in a lot of effort to find that only. So, they are sorted by relevance typically. So, how to define relevance? Well, a simple heuristic is used here. Well, over all the words in the query, like for example, I have given test symposium 2005, there are 3 words. Find the sum of the product of the words weight in the document and its weight in the query. See, here there are 2 terms we have introduced: weight of a word in a query, weight of a word in a document. Now, in a query, very rarely we type in an English question. Some keywords we type in some order as it comes to our mind. So, most likely the word that you have typed in first is the most relevant one. Next one is the next relevant. So, the weight of a word in a query can be very easily determined by its position in the query string. Similarly, the weight of a word in a document can be judged using some heuristics, as we had mentioned in our last class, like whether the word appears in the title, whether it appears within a sentence or a paragraph, towards the beginning of the document, and so on. These are a few measures which you can use or combine to provide or produce some kind of a quantitative estimate. So, after finding the sum of the product of the word's weight and its weight in the query, you divide it by the number of total words in the query, total number of words in the query. So, this is how the query server of web crawler determines a numerical relevance figure when it is trying to sort the results. Now, talking about the query processing time, typical benchmarking has shown that it was able to process 8 to 10 queries per second. Of course, if the queries are very complex, it may require more time, but these are very typical queries that have been benchmarked against. So, this processing time that we are talking about here, this consists of a number of different components. The query has to be parsed. There can be just simple words, there can be quotes, there can be other special characters and or not connectives and so on. So, the queries has to be parsed. You will have to invoke the database server to search for the index values, perform the query match, retrieve the results from the database. Well, of course, ranking by relevance will also come here. Then it will also have to format the search results as an HTML page, because all these processing are being done by this server at the server side, but the user is still sitting on the browser as the client. So, it has to come back to the user as a nicely formatted HTML page. So, after doing all these things, it has to be formatted in the form of an HTML page in a nicely formatted way. So, and they will be send them back to the HTTP server. Okay. So, this is how web crawler works. Now, you see, with this idea, it will not be difficult for you to develop your own search engine. Let us try to see what are the things you need to know in order to develop a search engine from scratch. First and foremost, you need to know how to retrieve a page from a web server given its URL. That is the standard HTTP GET command. So, using the GET command, you can retrieve a document or the POST command. Okay. So, that part is done. Given a URL, it is possible to retrieve a document. Second thing is that you will have to maintain the database. So, as you are scanning through the web, as you are scanning through the links, you will be building your own information base in terms of the index structure, the dictionary. So, once you have dictionary in place, there will be another layer on top of it, which will talk about the query processing. The user will be typing in some query at the back end, the queries will be processed and the index values will be searched, and whatever algorithm you follow, you can follow something like Alta Vista or you can follow something else also. But basically, these are the few different things that you will be requiring to do that. So, with that we come to the issue of means how many agents are required, because see, we have talked about so many different things. We have talked about the query server, the search engine software, we have talked about the database, but how many agents are required? Agents I had mentioned once when we talked about the search engine, that search engines will be sending out requests for retrieving pages given the URLs depending on the number of links that are going out from a page. Now, as I said, it will be faster if this process can be started together concurrently. So, what web crawler does? Web crawler runs agents as multiple concurrent processes or threads. Well, it depends on the implementation. Typically, up to 10 or 15 such processes or threads are run. This is actually used to circumvent the waiting time for accessing server network resource, because the thing is that if the search engine is trying to build up the index sequentially one after the other instead of spawning concurrent agents, what might happen is that one particular page it is trying to retrieve, due to some network congestion, it is taking a considerable amount of time for the page to be downloaded. So, during this entire duration, the search engine will be lying idle, but if it is done concurrently, maybe some other pages have come in the meantime, so it can start processing them. Okay. So, this is the basic idea. So, with this we have come to the end of our lecture number 39. Now, here basically, as I said, we had talked about how search engine works with a specific case study, web crawler. This is a very interesting implementation of web crawler. So, how web crawler works, what are the basic concepts and strategies web crawler uses, and some heuristics also we have talked about. Okay. So, with this background, I believe you can take up a project of developing your own web server if you want to. But actually my objective in this class was to give you some underlying understanding of how web server works, so that you know how to go about the implementation if it is required at some point in time for you in the future. So, let us now move on to the solutions to the quiz questions of the last class. The first question was, what is the basic purpose of search engine. Well, search engine, as I have said repeatedly, it is a software program that helps in locating information stored on a computer system, typically on web servers, World Wide Web of course. What is the difference between a crawler based and a human powered search engine? Now, crawler based engines, as it said, they will go from one website to another automatically. They will be exploring the web and create the listings and the index, dictionary index automatically. However, in a human powered engine, here the author of the web page has to submit a short description for being included in the listing. So, as long as the author does not submit it, the corresponding page will not be indexed. Okay. So, for the purpose of indexing, you will have to submit the keywords and other information description about your website. Fine. In a crawler based search engine, what is a crawler? A crawler is also called a spider. The main purpose of it is to visit a web page, retrieve the web page. This can be done using the HTTP protocol, and after retrieving it can look at the contents and find out the hyperlinks. It will follow the hyperlinks that are present in the document to other pages within the site. Now, it visits the site regularly. As I said, it can be once a month, it can be more frequent also, and look for changes. If there are changes, they are again brought, they are again downloaded. So, in a crawler based search engine, what is the index? Well, index is a huge book or a dictionary that contains a copy of every web page that a crawler finds. This is used during the time the search or the query processing is done. What is the purpose of the software tool Archie? Well, Archie was used to download directory listings of all files on anonymous FTP sites and create searchable database, so that later on when users submitted some queries based on some keywords, it would search the database and will give you a listing of the anonymous websites where possibly the information you are requesting for can be found. Do the search engines crawl through the entire web? Explain. No, I have mentioned because of the sheer size of the web, it is not possible. So, search engines like that web crawler we have seen the design, they crawl a small fraction of the web at moderate frequency. Blogs, news sites which change very frequently, they are crawled at higher frequency. So, you should make a distinction that which of the sites are blog sites or such news sites. How can a search engine automatically generate the keywords from a document? Well, we had mentioned that the search engine can extract words from the document and index them depending on their significance. Like, it considers several heuristics here. So, I am repeating the title of the page. So, the words appearing there can be considered to be significant. Words repeated many times, they may be considered to be significant. Those appearing towards the beginning of the page, they may be more relevant as compared to those which are appearing towards the end. So, these are some heuristics you can use to just automatically extract some useful information about a document, okay, without seeing it in front of you. How is the page relevance typically measured? By search term frequency and the position in the document, this is one, and how many links are pointing to it from other places. These are some typical measures. What is a meta tag? How is it specified in HTML file? Meta tags, actually they specify some information including keywords in the document. They are specified using the meta tag. How can we prevent a crawler from using the keywords meta tag information for indexing? Well, if you just include this line in your HTML document, this will prevent the web crawler from indexing your site. Meta name equal to robots, content equal to no index. Why do some very popular search engines do not index using keywords meta tags? Because I mentioned that there are many web authors who use false and misleading keywords in the meta tags for the sole purpose to increase their page hits. See, there are many websites where there are a lot of advertisements and they gain revenue by the number of hits, number of people that visit their websites. Just to increase the revenue, they can include very popular keywords in their meta tags so that many people visit their page by accident or otherwise. Okay, so they can generate or they can earn more amount of money out of their advertisements and other ventures. Now some questions from today's lecture. What are the basic functions of web crawler? What are the key design goals of web crawler? How is the index generation problem mapped into a graph problem? Does web crawler retrieves every file being pointed to for the purpose of indexing? Explain. How does web crawler function in the indexing mode? What is real-time search? So actually we have almost neared the end of this course. Today's lecture was the 39th one. In the next lecture we shall be concluding our course by providing a summary of whatever we have covered so far, and also I will try to give you a few pointers to further studies and further explorations. This should be considered as just a platform from where you can explore new things, because this internet is a vast and a very fast changing technology. So unless you keep yourself updated, you will very soon become obsolete. So we shall be talking about these issues in our next and last lecture. Thank you.